Okay, example 2. What are the sine and cosine of a negative 45-degree angle? So again, the problem is cosine of negative 45 degrees equals something. Sine of negative 45 degrees equals something. So that's the question happening here. What does negative 45 mean? If 0 degrees is right here, if I'm going negative 45 degrees, which way do I go?
Down.
I go clockwise,
Yeah.
right? So when I'm dealing with the unit circle, if I'm going in a counterclockwise direction, my angle's positive. If I'm going in a clockwise direction, my angle is negative. Okay. And I advise clockwise, counterclockwise instead of down, up, left, right, because if I'm here, I'm going down, but if I'm here, I'm going left, now I'm going up, now I'm going right. So clockwise is always clockwise, counterclockwise is always counterclockwise. So just keep it simple that way. So negative 45 degrees would be clockwise in a 45-degree angle. So down here would be negative 90 degrees. Would all agree with that, right? So if I'm going this direction, I'm hitting negative 90 first. So negative 45 degrees would be sitting right here, where this angle is how big? 45 degrees, right? So if I draw my reference triangle here, and again, the reference triangles I gave you just a moment ago were all in radian form, but I could have drawn those reference triangles just as well in degree form. If this is 60, this is 30, this is 90, this is 1, this is 1/2, this is the square root of 3 over 2. Where this is the origin angle, right? So the cosine of 60 degrees is this number 1/2. The sine of 60 degrees is this number, the square root of 3 over 2. If I have a 30, 60, 90, where the 30 is the origin angle, again, the hypotenuse is 1, this is the origin. This is 1/2, this is the square root of 3 over 2. So the cosine of 30 degrees equals the square root of 3 over 2. The sine of 30 degrees equals 1/2. Then we got our 45, 45, 90. That's 45, that's my origin angle. So, just like the last problem, you graph the angle in standard form. Standard form, here's 0 degrees. We measure whatever direction they tell me to go, in this case negative 45 degrees, so that gets me right there. I draw my right angle in straight down like that. This is 1, because the hypotenuse is always 1, we're in the unit circle, always in the unit circle. And for 45, 45, 90, that's this one. This is the square root of 2 over 2. This is the square root of 2 over 2. Which direction horizontally from the origin am I moving? From the origin horizontally, which direction do I move? Left or right? Right. This is not a hard question. I'm not hearing a lot of feedback here. Everybody understands that's right, that's left, right? So if I'm at the origin here, and I'm going out to here, which direction do I go? Right. Right? So, that's right. Right is positive or negative? Positive. Okay? If I'm here and I want to go down to here, which direction do I go? Hint, I said the word. Here, down to here. Which I'm going down to here. Down. Right? Down. And down is? Negative. The horizontal is cosine, the vertical is sine. Alright? So, horizontal I'm going positive square root of 2 over 2. Vertical I'm going negative square root of 2 over 2. Again, the angle at the origin gives me the answers. I have to establish sine based on the quadrant we end up in. If I get a 45, 45, 90 in the third quadrant, I'm going left, negative, down, negative. If I'm in the second quadrant, I'm going left, negative, up, positive. If I'm in the first quadrant, right, positive, up, positive. Okay, so again, the quadrant you end up with establishes the signs, but the numbers are always gonna be these numbers for 30, 60, or 45. Those are the angles you're gonna be dealing with almost exclusively. All right, we don't jump into those uglier angles anytime in the very near future.